Hi everyone. So we're just going to finish going over some of our plots. This is still part of chapter 6, just the second half of it. I just didn't want to make the other video too long. So, this should be pretty quick. We're just going to cover two types of plots, and then we're going to, not two types, 4 types of plots. They'll still be pretty simple and all really similar arguments. And then we're going to cover 2 other kind of simple things that go along with it. Right, so in the manual, this section is labeled graphs using qualitative data. And I find the qualitative aspect or terminology kind of funny here because it's like qualitative data for a mathematician, not qualitative data for a social scientist, which is a little different. But either way, so we're gonna call this qualitative data, and what this is doing is using our categorical variables to make different plots. Right. So we're going to get to quantitative data after this, which is going to be our actual numerical data, but the difference between these is not super large here. Okay, so the first thing we're going to do is a bar plot. And so what we're going to run our bar plot on is the summary of our birth month. So let's remind ourselves what that is before we run an actual thing on it. So what is summary expenditure birth month? It is showing us for each category of month how many people are born in that month out of our data set. So you can see how these are going to make a bar plot, right? Okay, and then we have a few other arguments that are important to know. This is how you set your labels and your titles. So you are going to be asked to do this. So it's important to know what these are. Within bar plot, within plot, within a lot of different plotting functions in R, these are the exact same terms for setting these. So once you know it for one, you kind of know it for the others. So here you're going to start with the thing you want to plot, what data you're plotting, and then you're going to put a comma between all of your different terms. So the next thing we're doing is we're setting what we're going to label our x-axis as, and it's just x lab equals. Then you have to put in quotations what you want it to say. So here we're going to label it as month. Then we put a comma because remember we have to separate these arguments. Our y lab or our y-axis label is going to be count. Then main equals, that's going to be your title. So I know it seems intuitive to want to type out title equals, but it's not that. It is main. So it's really important to remember that. Main equals, and our title of this is going to be number of individuals born in each month. So if we run this, if you run it in R, it's going to pop up in a different window. If you run it in R Studio, it's going to pop up in my little plot window that's been blank for so long down here. All right, so we run it and we can see in my plots, we have a nice little bar chart. What can you do from here? You can zoom. So these are a couple of ways to kind of access your plot. So you can zoom into it. It'll pop up in a separate window. Sometimes what I do is I click on it and drag it out, and you can save it as a file if you do that. So maybe you're like, I don't know how to save things. This is too complicated. If you zoom into your plot window, just click on it and drag it. You can actually drag it to your desktop and it will save it as a file. That is the least elegant way to do it, but you can do it that way. You can also go to export and you can save as image, save as PDF, and here you'll actually be able to save these things somewhere. You do still have to, if you do this, save plot as PDF, you have to choose the size of it. You have to choose where you're gonna save it. So maybe you don't want to save it just in here. You can then go to directory and you can pick a different place to save it if that's what you want. And you have to choose a name for it. So let's do this as let's save it as bar plot underscore ex, for example. And so if we do that, all we have to do is press save, and it will save it for us. If I went and checked in the directory, it would then be there. So yeah. So saving things can be as simple as that. I will show you at the end of this video, though, one other way to save stuff and what is usually the preferred way to save things in R, or the preferred way to save plots in R. Okay, so next we're going to do a bar chart with labels for every month. So if you see here, it's doing January, April, June, August, November. So that's not the most informative. We really would kind of want our labels to show each month, right? So this option here, what we're going to do is, instead of looking just at how many people are born in each month, we're going to do our tapply function. So you can put, right, this is both examples of, you can put functions in for your data type, or for the data that you're plotting. So here we're doing that same tapply function to our commute expenditure, lumping it by birth month, but the function we're actually running is standard deviation. So what we're going to be plotting is the standard deviation of commute expenditure per each birth month. We're again setting our X lab to be month. Our Y lab is now going to be standard deviation because it's no longer count. We're now plotting the standard deviation. Our main is going to be standard deviation of expenditure on commute. And this last argument is what's going to make it so that we can see each one of those labels. We're going to do LAS equals 2. I can't really explain why it equals 2. The way that these options work in R is sometimes they're just labeled by numbers, and you kind of just have to get used to knowing what the numbers mean. So there's lots, and this happens a lot in plotting. There's a lot of different plot options that are specified by specific numbers, and if you're not sure what they are, you Google it. Like, if you're like, I don't know how to plot a line that is like a dotted line style, you can go look up, just Google it, and usually you'll be able to find an answer pretty quickly. Okay, so LAS equals 2, and you can see here now we have each one of these month labels is actually there, and what it's done is it's turned it horizontal. This way they actually fit. The reason they weren't all showing up here before is because they don't really fit like that, and R does try to navigate the space that you have. Okay, so that's how to make our bar plot look a little nicer. You can play around with colors and stuff too, but if you want to do that, I would recommend Googling it, because yeah, it's a pretty easy thing to find, and it's actually really important to get used to looking up how to do things like this in R that you're not sure of. All right, next we have creating a pie chart. So really simple, we're gonna do the same thing almost. We're gonna do our commute expenditure categorized or lumped together by our birth month, and we're gonna do the sum of it. That's going to make a pie chart out of the total expenditure, right? So this will show us for the total expenditure in our data set, how does it get divided by month? And here we're just setting a title, proportion of expenditure on commute. You don't have to do a lot for pie charts because they're kind of simple. And here you get a cute little pastel colored pie chart like that. Okay, so looks good, not too much to mess with. There are things you could play around with, but again, these have to do with different plotting options in R that you kind of just need to get used to. Okay, so saving things the way you should be saving things, or saving plots the way you should be saving plots in R. So what you do is there are different commands that will save them as different things. So here I'm choosing to save as a PDF. I could also save as a PNG by doing PNG and then, PNG and a parenthesis. I'm gonna save it as a PDF. That's what I save most of mine as. But it's, either will work. So you put the name of what you want to save it as, it's like as a command, and then open parentheses, and then you just want to put your file name in that. So this is going to be your file path here. Let's say I want to save it in my, not quite my working directory, right? I want to save it maybe somewhere else. Let's press tab, go to lab documents, and we can save this in our lab 10 folder. I think that'll be fine. And then you want to keep this slash here, and I need to now name what my file is going to be. So now maybe I want to name it like pie chart because I'm creative. So you have to have your directory. You have to then name what it's going to be after your last slash, and then .pdf. Okay, so now my file is in the my file directory is in the appropriate form, and here I can press enter. Now this did not create a pie chart for me. This just created the file that's going to store my pie chart. What I would have to then do is go right back up here, do this, and you can see it didn't show up in my plot window. It's not there. Like I plotted this twice now. There's only one of them here, and you can see that by scrolling through them. It plotted it in the place that I had specified prior to it. So now I have this PDF device activated or on, and I don't want it to remain on. I set it up, I did my pie chart, and now I'm done with it. So because of that, it's really important to remember to type dev.auth, open parentheses, and run that line of code. After you run that, it will turn off your devices. Sometimes you have to do it more than once. Also, it got rid of my plots in my plot window, which is perfectly fine. You can always run it one more time, and you want to run it until you get this, this result. So you want null device 1 to be what the result is that you get. Okay. I don't really expect many of you to save it that way. It is the appropriate way to save your plots, but that's totally fine if you don't feel comfortable doing it. I did want to show you how though. Okay. Next is accessing R documentation. So there are help files for all of the commands in R. And this is also true for any package you load in to your R session. All of the different things that are in that package also have their own help files. And so the way that you access this is by doing question mark and the thing that you want to know about. So maybe I want to know a little bit more about bar plot. If I do question mark bar plot and press enter, it will access this help page for me. And now I can actually, I'll make this a little bigger. Now I can actually look through this, and it tells me how to use this, this function appropriately. So it tells me what it does, what the title of it is. It shows me bar plot, height, and you can see all the arguments that go into bar plot, or at least all of the main arguments that go into bar plot are right here. So you can kind of take a look at them. You can see, oh, xlab is in here. That sounds like it's probably the one for xlabel. And you can kind of get a sense of it like that, right? Like xlim, that's probably going to be the limit for the axes, right? And then how you see this ... here, that means that there are other arguments that bar plot can take, but they're not going to be all specified here because it's just too much. There's too many arguments that could be passed to bar plot. And so they're just showing you what the main ones are. And then you can read a little bit more about it. So all of these individual arguments, like what is height? It'll then tell you what it takes. What is width? It'll tell you what it is. It'll tell you how to how to appropriately pass it to it. So yeah. And then if you're still confused, at the bottom, they always have examples for help pages. At least all the good ones do. So you can, if you're like still very unclear on how to use this, you can then go look at the examples at the bottom and hopefully get a better sense of how these things are used appropriately. And bar plot actually has a decent amount of examples. So yeah, that is how you use the help file. You can do this on any of those functions we've been doing. So yeah, like if we do question mark ABS, miscellaneous mathematical functions, it's one of them along with square root. It'll tell you what it takes, a numeric or complex vector array, and and gives you a little example. So yeah, the question mark is very helpful. If you don't remember how to do that for some reason, you're using RStudio, you can also go to this help tab here. So here we are on, we were on plots before. We also have our packages, which ones are loaded in. And we have help. If we click on that help tab, we can then type in things. So we can be like, what is bar plot again? And then I can click on it and it will pull up the same help page. So different ways of doing the same thing. All right, moving on to finish up quickly. We have our, we want to create a histogram. So this is the section now labeled quantitative data. This is quantitative data, which really is quantitative data according to a mathematician. Not saying that they're wrong though. Okay, so before we create a histogram, let's use our help page. Let's find out a little bit more about what the command hist does. If we do question mark hist, we can see histograms. So the generic function hist computes a histogram of the given data values. If plot equals true, the resulting object of class histogram is plotted by plot.histogram before it is returned. It's information, you probably don't have much use for it, but it tells you about it. And here we can see what it takes, right? So hist, the first argument is x. If we look down here, we can see that x is a vector of values for which the histogram is desired. So we now know that the form of our data, the form that our data has to take for our histogram to run appropriately is a vector of values. That's important, right? It tells you how the breaks are done. You can create your own breaks if you want. So breaks, it's Sturgis that basically based on your data, it chooses what breaks are appropriate. But you could set, like if you know your data better and you want to see a more fine-grained histogram, you could set breaks to be, like 10 or 100 or whatever is appropriate for your data if you want it to be more. Okay, lots of other things. Again, ... because it's a general plotting method and it has a lot of different things, arguments that it can take. Here, what we're going to do is do a histogram of our expenditure commute. So, yep, that's all. And our X label is going to be expenditure on commute. Our main is going to be histogram of expenditure on commute. And you can see here our column of our data frame is treated like a vector because X needs to be a vector. So each individual column of our data frame is essentially a vector on its own. Okay, so we have our expenditure commute, and we can see that for these breaks, like it's basically binning the data into different categories. And just to show you, if I did breaks equals, how many we have? Let's do instead 20 breaks. We can see that it's going to give us some more fine-grained breaks. So now I can see how it's broken down into smaller categories, which might help me understand my data a little bit better. And histograms are generally exploratory and are done to kind of get a sense of what our data looks like. All right, last one, creating a box plot. The command is very intuitive. It is box plot. We are going to do a box plot of our expenditure commute. We are going to label our y-axis expenditure on commute. Our main is going to be box plot of expenditure commute. And it's fairly simple. Just a box plot here, right? It shows the spread though, which is helpful, max and min, our interquartile range and our mean. So yeah, just a little box plot of the expenditure commute. So next video will be the last one. We're going to get onto linear regression. It's some stuff that we've actually seen already in Excel, actually. It's a pretty short chapter, so it hopefully won't take too long. And yeah, there is, if you did look on Canvas, there's a section labeled hypothesis testing. We're not going to have time to get to that, so you really don't have to worry about it. So yeah, the test will cover everything from the first video to the next video, which is the last one. So yeah.